Good morning, Tehmina Khan is here. In this video, I will explain a question of differentiation from P3 A-level mathematics, CAIE syllabus. And this question is from June 10, variant 3.1, and it is question number 9. Most of the students usually find this question very difficult to solve. So I am just explaining it here. And on the top, you can see the blog address. This is a blog address of mine, and the link of all my previously made video is posted up there. Okay, so the question is, which is from June 10, variant 3.1. It seems very small, so you can actually refer to the question. So the diagram is given to you, and the equation of the curve is also given to you, which is root 1 minus x, 1 plus x. And there are two parts of the question. The first part of the question is saying to differentiate it and express dy over dx, and you have to differentiate 1 minus x, 1 plus x, and you have to show that normal to the curve at the point xy is this. So you have to basically end up at with this result, right? So you have to show that the normal to the curve at the point where it is x comma y are the coordinates is this. And second part of the question is saying find the gradient of the normal. Now this is your normal, which you will find out. The question is saying the gradient of this normal has its maximum value at the point P. Point P was shown in the diagram, so just a visual image. And you have to find the x coordinate of this point P, right? So question is saying find the gradient of the normal, and this is the equation of the normal, has its maximum value at P, and find the x coordinate of P. So let's see how we will start. So let's start with the first part first. So the curve equation was given to you, root 1 minus x and 1 plus x, right? And you have to differentiate 1 minus x divided by 1 plus x without root. Therefore, you will simply apply u over v formula. Now this part most of the students find easy, right? So u over v quotient rule, and we know it is v square v u prime minus u v prime. So simply I am applying that formula here, and I ended up with minus 2 divided by 1 plus x whole square. After that, question is saying show that the gradient of the normal to the curve at point xy is this. Now I have to find out the equation of gradient of the normal, which is this. And whenever you differentiate the equation, you actually get gradient of the tangent. And this is also not the actual curve. Actual curve was with root sign, right? And we have done without root. So let's see what is the next step. So I actually have to differentiate this now. Yes or no? Okay. So if you differentiate this, it's like a composite function. The whole function has power half. So if you apply differentiation on it, I hope you know the prerequisite knowledge which is required here. So half will come here, function as it is, half minus 1, multiply by the differentiation of this, and that's why I've written here. Okay, differentiate this with respect to x. And this is what we have just found in the previous part, because the previous part was saying differentiate this, and we got the answer what? Minus 2 divided by 1 plus x whole square. This is what we have gotten. So that's why I have replaced this whole part with this. Okay, so continuing it, this I have just copied down as it is. Okay. So after that, what I'm doing here, just bringing this 2 out here. That's why it is here. And this minus sign is also going out here. And nothing else I have done so far. So 2 cancel out, and I got this thing. Now question is saying find the gradient of the normal. Now for the gradient of the normal, what I'm doing now? Can you tell me what I'm doing here? I have inversed it. Whatever is in the denominator, I have written it in the numerator, because the difference between the gradient of tangent and normal is that they are inverse of each other and with opposite sign. So if it was negative, gradient of normal will be positive. So these two terms I have written in the numerator. You can see 1 minus x power half, it is in the numerator. 1 plus x whole square, it is in the numerator. 1 plus x power half is in the denominator. Now this is the gradient of the normal, but it does not have the form which is required in the question. Right, you remember that form. What was it? It was 1 plus x bracket and root 1 minus x square. So you have to bring it into that form now. So let's see what I'm doing here. If you see this and this is same. So if I apply the concept of indices and consider this as a base, so I can take this up. So 2 minus half. This is what I'm doing here. Right? So it will become 2 minus half is equals to 3 over 2. Okay. So now after that what I'm doing here, 3 over 2 mean 1 plus half. So I'm splitting this into two parts, power 1 and power half. Yes, because this 3 over 2 mean 1 plus half. So I'm writing it separately. Now if you remember, when power is same, you can write them together. So this is what I'm doing here. And half power mean you can remove it, replace it by the radical sign, which is root sign. Okay, so now 1 plus x, 1 minus x is reminding me 1 square minus x square. So this is what I had to prove. Now the second part of the question was saying that the gradient of the normal, right? Now the normal we have found. To find the gradient of this normal, what will I do? And question was saying that it has maximum value at P. I have just dotted down the main point here again. And we know that whenever we are talking about maximum value or minimum value, it means rate of change is 0 there. So what I will do, I will differentiate this equation again using U into V formula, which is a product rule. So now I am differentiating it again. Now you understood why I am differentiating, because question was saying, I am repeating, that it has a maximum value at P and what? The gradient of this normal curve. So that's why I am differentiating it. So now U is 1 plus x, so it will be plus 1. And V is root 1 minus x square. Again a composite function. Power half will come here. 1 minus x square as it is. Half minus 1. Multiply by differentiation of this, which is minus 2x. So 2 will cancel with 2. So I will be left with this. So I have U, U prime, V, V prime, which I will simply substitute in the formula. Now mostly this form is a problem at times for student, because otherwise you have to do simple algebraic calculation here. So these two are multiplying and this is dividing by it, right? Now what is here? Denominator is 1. When denominator is 1, you can multiply it by this, so that you can take a common denominator here. Simple LCM rule, right? So when this will multiply by this, root times root, root will go away and it will be 1 minus x square. After that I am simply opening the removing the brackets in the numerator. So I ended up with the equation minus 2x square minus x plus 1. So it's a quadratic equation and I'm solving it now, right? Okay, so now when I'm solving it here, I got x equals to minus 1 and x equals to half. Because it was said that you have to find the x coordinate at point P, and point P was on the right hand side of the vertical line, it means x is positive, and that's why I'm taking x equals to half into consideration. So this is my answer. So thank you very much for watching this video. If you have learned something or you liked it, please press the like and subscribe button, and I would appreciate your comments. And if there is any particular question you want me to solve, you can write it in the comment and I will try to reply or make video on it as soon as possible. Thank you very much. Have a nice day.